The C10K problem. One thread per connection stops scaling. This video explains what replaces it. A server must handle many client connections at the same time. The count rises from 10 to 100 to 1,000 to 10,000. The target is 10,000 concurrent connections on one machine. One model gives each connection its own thread. Each thread reserves a stack, commonly 1 to 8 megabytes by default. 10,000 threads reserve gigabytes of memory. The kernel scheduler must time slice across every runnable thread, and context switch cost grows with their number. The bottleneck is per thread overhead, not CPU work. Now use one thread for all connections. The problem is how one thread watches many sockets without blocking on any single one. The answer starts with non-blocking file descriptors. A read on a non-blocking descriptor with no data returns immediately instead of blocking. The select and poll calls take the whole set of file descriptors. On each call, the kernel scans every descriptor to find which are ready. The cost is order n per call because the full set is examined every time, even when only a few are ready. The select call also caps the set at fd_set size, which is typically 1024. Epoll splits the work. Epoll_create makes an instance, and epoll_ctl registers each descriptor once into a kernel-side interest list. Epoll_wait then returns only the descriptors that are ready. The kernel keeps the ready list across calls, so cost scales with the number of ready descriptors, not the total number watched. kqueue on BSD in Mac OS and IOCP on Windows are the platform equivalents. Epoll has two modes. Level triggered keeps reporting a descriptor while data remains, so a handler can read once and return. Edge triggered reports once when the state changes, so the handler must drain the descriptor fully, looping until the read returns egain. The event loop puts it together. It calls epoll_wait, then runs a handler for each ready descriptor. Handlers do non-blocking reads and writes and never block, then the loop repeats. One thread, one loop, 10,000 connections. The nginx worker loop, the Redis event loop in ae.c, and Node.js through libuv are real implementations. Thread per connection. Cost grows with the number of connections. Epoll-style readiness notification. Cost grows with the number of ready descriptors. The event loop is one non-blocking thread driven by readiness events.